Most AI agent failures don't announce themselves with crashes or error logs. They slip through as quiet degradations, a 10% failure rate that only surfaces weeks after launch, buried in user complaints and edge case reports. The model isn't the problem. The architecture around it is. A 90% success rate sounds impressive until you multiply it across thousands of daily interactions. That's hundreds of silent failures accumulating in your user's experience every single day. Teams celebrate the launch and move on, not realizing they've taken on technical debt measured in broken trust rather than broken code. Think of an agentic pipeline like a relay race. The fastest runners in the world still drop the baton at the handoff. Every tool call, every output interpretation, every branching decision, those are handoffs. Teams obsess over building faster runners and completely ignore designing safer exchanges. That's where the race is lost. When a tool returns null, or a web fetch times out midstream, or an output is technically valid but semantically useless for the next step, what does your agent do? If you didn't explicitly design that moment, the agent fills the gap with its own judgment. Sometimes that works, but improvised behavior in production systems is essentially untested behavior, and untested behavior is risk. The discipline shift here is small but profound. Before wiring up a tool call, write down 3 things: what full success looks like, what partial success looks like, and what the agent should do when it receives something unexpected. This transforms a plumbing decision into a deliberate design decision. Documentation becomes your failure insurance policy. There's a hidden tax on every shortcut taken during agent design, and that tax is paid at the worst possible time, when something breaks in production, intermittently, in a way you cannot reproduce in a dev environment. An hour of structured edge case thinking before deployment is worth days of forensic debugging after. The math is not even close. The best agentic systems aren't built by the teams with the cleverest prompts or the largest context windows. They're built by teams who asked a disciplined question after every design decision: how does this break? Map your 5 most likely failure scenarios for every critical transition. Agents that survive real-world usage are the ones someone stress-tested before users did. Building AI agents that hold up over months of real usage is fundamentally a craft discipline, not just an engineering one. The core reasoning loop is table stakes. The signal that separates durable systems from fragile ones is whether someone cared enough to think hard about what happens when things go slightly, quietly wrong. That mindset is the real competitive advantage.